Okay, this one, the sound is working. That's good. Okay, good. Carrying on to question 11. It says, in the diagram, the vertices A, B, and C of triangle ABC are concyclic. So that means they all, cyclic means circle, they all lie on the same circle's edge. Okay. EB en EC is raaklyne aan die cirkel. Tangents, immediately you have to know there are certain things that we can do when we are working with tangents. Okay. And then they say T is a point on AB such that those two lines are parallel. So I'm just going to indicate the parallel lines clearly so that we know for those you are allowed to use alternating angles, co-interior angles, all of those. Okay. Goed, en dan sê hulle vir jou BC sny TE by F. Is T the midpoint of the circle? Read through the whole description again if you have to. It's a point. It's not the midpoint. So don't get sucked in with what you want to be true. Nee? Hulle sê nêrens vir ons T is die middelpunt van die sirkel nie. So you cannot assume it is. Okay. Goed. That's not nice. Sorry, ek net gou hierdie goed weer regmaak. Okay, ek weet nou nie wat nou aangaan nie. Hulle vra vir ons bewys dat B1 gelyk is aan T3. So I have to go from B1 to T3. What? Okay. I like to start off by saying, let's set B1 equal to X. I don't know why, it just makes it a bit easier. Okay, goed, so doen dit vir jouself, sê vir jou daai en is gelyk aan X. En nou is jou werk om te gaan kyk, hoeveel ander hoeke kan ons nou gelyk kry aan X. So I'm going to start looking for other angles that are equal to X as well. Okay, now we haven't in this exercise so far done the tangent chord theorem. So let's quickly discuss the tangent chord theorem again. The tangent chord theorem says, if I have a circle, and I have a tangent, and I have another chord in the circle, then the angle formed between the chord and the tangent will be equal to the angle in the opposite circle segment. Okay, so jy gebruik die chord as die basis van 'n driehoek. You use the chord as the basis of a triangle, and then you say the opposite side of that triangle will be equal, or the opposite angle in that triangle will be equal to that angle. Good. Okay, so let's use that. I'm going to use this as the base of the triangle because that's the chord. Which angle is opposite to that chord? Yeah, what do you call that angle? This one. Angle A. Do you see? Want as hierdie die basis is van die driehoek. Do you see that's a chord? And then there's an angle formed between that chord and the tangent, which we assigned X to. Then that must be equal to this. Tan chord theorem. So die hoek tussen die raaklyn en die koord, as jy die koord gebruik as die basis van 'n driehoek, is gelyk aan die koord in die teenoorstaande sirkelsegment. Okay, so now I have another angle equal to X. Now we want to go there. Look at your parallel lines. Do you see that this angle will be equal to that angle? Because corresponding angles. Ooreenkomstige hoeke van TE is parallel aan AC. So now you've proven what you had to prove. If all of them are equal to x, then it means that B1 is equal to T3 because they all have the same values. Yeah? Okay, next up. Prove that TBEC is a cyclic quad. Yeah, and then you just work from one point. Okay, what? TBEC. Okay, I have to prove that that is a cyclic quad. Now, I want to quickly pause this here and show you how we prove cyclic quads. Okay. Ek het dit al genoem in die verbygang. So daar's 3 verskillende maniere om te bewys dat iets 'n koorde vierhoek is. Die een is omgekeerde.
Asseblief, dis tyd vir afkondigings vir eerste pause. Dis asseblief vir afkondigings vir eerste pause. Dankie.
The converse of that theorem. So that theorem says that the opposite angles of a cyclic quad is equal to 180 degrees. So if I give you a quad, any quad, and this is x, and this is 180 minus x, do you agree that then these will be supplementary? If you add those together, you get to 180. Do you agree? So then this thing must be a cyclic quad because the converse of opposite angles of a cyclic quad. So ons gebruik die kennis wat ons het van 'n koorde vierhoek om te sê dan kan hierdie vierhoek net 'n koorde vierhoek wees omdat hy hierdie ook bevredig. Dis ja. Oopsie. Yeah, we did it last term, but we're doing it again now. This is the second one. Die omgekeerde van die buitehoek van die koorde vierhoek. So because the exterior angle of this quad is equal to the opposite interior angle, this must also be a cyclic quad. And then the third one is using the strictasie. Stop it, you dom ding. So if you have a quad and you have that tie, the bow tie, then it's converse of angles in the same circle segment. Okay. Yeah, but you say converse.
It's like the same thing you get in a circle, but it's in a bar.
And you're just almost reversing the theorem. Okay. Grade 11s, I'm going to stop there. So check if you guys can do that one on your own. And then tomorrow in class, I'm just quickly going to mark your trigonometry homework, and then I'm going to carry on with revision on this.